Hello and welcome to Plain Peptides. In today's episode, we're going to be looking at the peptide known as GHK-Cu, a discovery made almost by accident, a peptide so small it's made of just 3 amino acids and effects that reach right down to the level of your DNA. Let's start with the name. GHK stands for glycyl L-histidyl L-lysine. Those are the 3 amino acids it's made from, just 3 bricks in our Lego analogy. One of the tiniest peptides ever studied. Cu is the chemical symbol for copper, so GHK-Cu is this tiny 3 amino acid bonded to a copper ion. Where does it come from? It is naturally occurring or produced in our bodies. It's found in your blood plasma, saliva and urine, and it's been there your whole life. Your body makes it and uses it as part of its own maintenance and repair system. But the amount of GHK your body produces declines significantly as you get older. What is its origin story? In 1973, a researcher named Dr. Lauren Pickart made a curious observation. He was working with human liver tissue and he noticed something strange. When he added plasma taken from young people to liver tissue taken from older people, the older cells started behaving like younger cells. They started producing proteins the way younger tissue does. Something in that young plasma was essentially resetting the older cells. In trying to figure out why this was happening, he tracked it down to this tiny 3 amino acid peptide, GHK. And that discovery has driven decades of research ever since. Because if a naturally occurring peptide can cause older cells to behave more like younger cells, the implications for regenerative medicine are huge. What does the science actually say about GHK-Cu? The research, including some studies published in peer-reviewed journals and work conducted using Broad Institute's gene mapping database, shows several key effects around collagen and elastin production, wound healing, anti-inflammatory and antioxidant effects, and angiogenesis. So starting with collagen and elastin production, GHK-Cu stimulates the synthesis of collagen, the structural scaffolding that holds your skin, tendons, and connective tissue together, as well as elastin, which gives tissue its snap-back quality. Looking at wound healing, research shows that GHK-Cu accelerates wound closure, supports healing across skin, gut lining, bone tissue, and other tissues. Moving on to anti-inflammatory and the antioxidant effects, it reduces the signaling molecules that drive chronic inflammation and it neutralizes damaging free radicals in the body. Finally, angiogenesis. Like BPC 157, it supports the growth of new blood vessel supply to healing tissue. Now, not only does it have the effects like the ones I've just mentioned, but there's also something else significant that it does. Research using gene expression data has shown that GHK-Cu can influence the activity of over 4,000 human genes, essentially resetting certain cellular programs towards a healthier, more youthful pattern. Switching on genes involved in repair and regeneration, and switching off genes that drive inflammation and breakdown. Coming back to that age-related decline I mentioned earlier, at the age of 20, your body has around 200 nanograms per milliliter of GHK circulating in your blood. By the time you get to age 60, that's dropped to around 80 nanograms per milliliter, and that's more than a 60% decline. Researchers believe that this drop correlates directly with the body's reduced ability to repair itself, regenerate skin, and maintain tissue quality as we age. GHK-Cu is one of the most extensively studied peptides in regenerative science, and it's been used in cosmetic skincare products for decades. The safety profile is well established and the research continues to grow, which is great news. From here, the series gets even more interesting. We'll be talking about the enhanced games next, going deeper into scientific research, talking to experts and breaking down more compounds as we go along. Hit subscribe so you don't miss a single episode, and if this series has been useful to you, share it, because the more people that understand this science properly, then the better it is for the world of peptides.